Hello and welcome back to Joe's Math Tools. In our session today, we are calculating the HCF when we're using the division ladder. And if you're ready, let's get started. In our example today, we will be calculating the HCF of three numbers which are 45, 27, and 54. And in calculating the HCF of these three numbers, we will be using one division ladder. Now, I'm going to go through prime factorizing these numbers using the division ladder. And then once we've prime factorized all of our numbers, then I'll go back and show you how to identify the numbers that we will be using in calculating our HCF. Now, whenever using the division ladder, you must remember that we use prime numbers only. So you only use prime numbers. And if you don't remember your prime numbers, we'll begin by listing our prime numbers that are under 20. These numbers are 2, 3, 5, 7, 11, 13, 17, and 19. So these will be the numbers that we will mainly use to factorize the numbers on our division ladder. So since 45 is my first number, I'll begin by focusing on that number first. So I'm looking for a prime number that I can divide 45 by. And a prime number that I can use to factorize 45 is going to be the number 3. So I'm going to begin with the number 3. So 3 can divide into 45 15 times. 3 can also divide into 27 9 times. And 3 divides into 54 18 times. Okay, so now we're still continuing on with our 15. So I'm looking for a prime number that I can divide 15 by. And again, I will be using the number 3. 3 divides into 15 5 times. 3 divides into 9 3 times. And 3 divides into 18 6 times. So now still focusing on my first column. So I'm looking for a prime number that I can divide 5 by, and since 5 is listed, I will use the number 5. So 5 divides into 5 once. 5 can't divide into 3, so we're going to return 3 back to our working. And 5 can't divide into 6 without a remainder, so we return 6 back to our working. And please remember that with the division ladder, there are no remainders. So if the number does not divide out completely, find another prime number that you can use. Okay, so now that I'm finished factorizing my first column, once I get to 1, I usually stop, and then I'm going to move on to the next column. So I'm looking for a prime number that I can divide 3 by, and again we're going to use 3 again. So we're returning our 1. 3 divides into 3 once. 3 divides into 6 twice. So we're now looking for a prime number since we're done with our first and second column that we can divide 2 by, and 2 is also listed in my prime number, so we will be dividing by 2. So we're returning our 1, returning our second 1, and 2 divides into 2 ones. Okay, so now that we have prime factorized our numbers 45, 27, and 54, this part is very important. Step now is very important. Now, when it comes to the HCF, when you're using the division ladder and you're using all 3 of the numbers on the same division ladder, you're looking for the point on that division ladder where you divided your prime factors. I remember that these numbers on your division ladder are your prime factors. So I'm looking for the point on this division ladder where my prime factor divided into all 3 of these numbers at the same time, or on the same line, I should say. So we're looking for the point on our division ladder where our prime factor divided into all 3 of those numbers. Now, I must stress this. Yes, it can be a line where the prime factor may have divided into two of the numbers like we have here with 3, and we just brought down the 1. But remember that in looking for the HCF, it has to have divided into all 3 of the numbers. So in looking at my first line, my 3 divided into the 45, it divided into the 27, and it also divided into the 54. So I'm going to circle that 3. On my second line, 3 divided into 15, 3 divided into 9, and it also divided into 18. So I will also circle that 3. On my third line, 5 only divided into 5, but not the 3 or the 6. So this one will be excluded. On my next line, 3 divided into, since my first column was already factorized, that eliminated my 3 because it can't divide into the first number. Same thing on my third and on my final line, the 2 also only divided into the 2, so that number will also be excluded. Okay, so now that we have circled these numbers, we're now going to calculate the HCF. So my HCF will equal to, that's 3 times 3, which is equal to 9. So in calculating our HCF, my HCF for 45, 27, and 54 is 9. And if you're someone who is familiar with your timetables or even with the factors of these numbers, then you will know that 9 is a part of each of these numbers factors. And also when looking at the 9 timetable, you will find that each of these numbers are also in the 9 timetable. So that's a good way for you to be able to check your answer just to verify if the answer that you calculated is indeed correct. And if you can't identify a timetable, you can always list the factors of these numbers as well. And in listing the factors, that will also help you to check if your answer is correct. Okay, so there you have it. We just use the division ladder to calculate our highest common factor of 45, 27, and 54. And in this session, all of these numbers had a common factor that we could use. So I hope that you get some practice in. Remember to further develop your skills, and we'll be right here in the next video on Jules Math Tools, where we make math easy.